Imagine, if you will, the world just before the sun crests the horizon. There is a specific kind of silence that exists in a meadow at dawn, a hush so deep it feels as though the earth itself is holding its breath. In these early pre-dawn moments, the air is perfectly still. The dew has settled into a silver veil over the tall grasses, and the only movement is the slow rhythmic fading of the stars. It is a time of waiting, a transition between the deep rest of night and the gentle invitation of the morning light. In the language of ecology, a meadow like this is often referred to as a climax community. This beautiful term describes a landscape that has reached a state of biological grace and stability. It is not a place of chaotic growth, but a place of balance, where the grasses, the wildflowers, and the microscopic life within the soil have found a way to exist in harmony. Left to its own devices, this meadow will remain much as it is for generations, a self-sustaining sanctuary that breathes with the seasons. But right now, at the tail end of winter, the meadow is still. It is a masterpiece of potential, tucked under a thin, crystalline blanket of frost. As we prepare to follow this meadow through its awakening, I invite you to settle deeply into your pillows and find a position that feels entirely effortless. If these gentle explorations of our natural world help you find a sense of peace, you're always welcome to join our quiet community here by subscribing, ensuring you have a restful place to return to whenever you need to drift away. But for now, your only responsibility is to listen. Let your breath become slow and easy, matching the patient pace of the earth beneath the snow. There is a precise chemistry to the arrival of spring. It isn't merely a date on a calendar, but a response to the warming of the environment. Deep within the frozen soil, the roots and buried seeds are waiting for a very specific signal. For much of the life in a temperate meadow, that signal is a temperature of approximately 40 degrees Fahrenheit, or about 4 degrees Celsius. This is the threshold where the molecular machinery of life begins to stir. Below this point, the water inside plant cells is too sluggish for movement, and enzymes remain locked in a state of suspended animation. But as the sun begins to linger a little longer each day, and the earth absorbs that golden energy, the temperature creeps toward that magic number. It is the moment the biological clock begins to tick, starting a slow, inevitable journey from the dormant brown of winter to the vibrant, living green of spring. The light is changing now. The deep indigo of the night is softening into a pale, translucent gray. You can see the outlines of the tall, braided stalks of last year's grasses, bowed low under the weight of the frost. It looks like a world made of glass, fragile, old, and slant. But beneath this icy exterior, the great thaw is already preparing to begin, starting with the very ground beneath the snow. Imagine the first afternoon when the air feels fundamentally different. It isn't quite warm yet, but the sharp crystalline bite of the wind has softened into something more forgiving. The snow, which has been a heavy and unyielding blanket for months, begins to change its very structure. It becomes granular and heavy, eluding its fluffy lightness as it settles and starts to weep. This is the science of the thaw, a beautiful transition of phases where the solid world begins its slow return to a liquid state. As the snow melts, a tremendous physical weight is literally lifted from the soil. A single square meter of deep snow can weigh hundreds of pounds, pressing down on the dormant life below. As it vanishes, the earth beneath seems to take a long, slow, and relieved breath of its own. But even before the snow has fully disappeared, there is a secret world existing in the narrow space between the white drifts and the dark earth. Scientists call this the subnivium layer. It is a thin, protected microclimate where the temperature remains remarkably stable, often hovering just around the freezing mark even when the air above the snow is many degrees colder. Snow is a masterful insulator. Its complex crystalline structure traps pockets of air, functioning much like the down feathers of a bird or the soft fibers of a thick, warm duvet. This insulation protects the delicate roots of the meadow and the dormant insects tucked into the grass from the killing frost of the open winter air. Deep within this subnivium world, the soil is far from dead. Even in the deepest part of the season, billions of microscopic organisms, bacteria, and fungi are quietly and industriously at work. As they break down the organic matter left behind from last autumn's fallen leaves and faded stems, they engage in a process called cellular respiration. This process is, in essence, a slow-burning biological furnace. Just as your own body generates warmth through the energy you consume, these tiny microbes release a minute but measurable amount of heat as they work. In a healthy, undisturbed meadow, this collective metabolic fire helps to warm the soil from the bottom up, meeting the sun's warmth as it travels down from the surface. As you think of the earth resting beneath its winter coat, take a moment to notice the sensation of your own body in this moment. Feel the gentle, steady pressure where you meet the mattress, a supportive weight that allows you to let go of any effort. Just as the meadow is held by the solid ground, you are held and supported by your bed. There is no need to hold yourself up. The earth and the room around you are doing that work for you. Let your shoulders drop a fraction deeper, and let any remaining tension drain away, mirroring the way the frost is beginning to seep into the thirsty, waiting soil. With the weight of the snow receding and the subnivium layer warming, the stage is set for a quiet revolution. The water from the melting ice trickles downward, carrying oxygen and vital minerals to the thirsty roots below. The brown matted grass of the previous year is still there, flattened and dull, but if you were to look very closely at the base of the stems, where the earth is darkest and dampest, you would see that something is changing. The first microscopic hints of emerald are beginning to push through the mud. These are the pioneers of the new season, the brave first signs of green that refuse to wait for the tall trees of the forest to wake up. They are the early arrivals, preparing to claim the light before the world becomes crowded again. Among these early pioneers is a group of plants with a name that sounds like a whispered secret: the spring ephemerals. The word ephemeral means lasting for a very short time, and for these flowers, brevity is their strategy for survival. They are the sprinters of the meadow, waking up while the great oaks and maples are still deep in their winter slumber. They have a narrow, precious window of time, a few weeks of direct golden sunlight reaching the meadow floor before the trees above begin to unfurl their heavy leaves and cast the world below into deep, cool shade. To look at them, you would see a portrait of fragility, yet they possess a hidden strength that allows them to thrive in conditions that would wither a summer rose. Perhaps the most iconic of these is the snowdrop, known scientifically as galanthus. Its name comes from the Greek words for milk and flower, a fitting description for its pure white petals that hang like heavy droplets of cream against the dark, damp earth. But beneath its delicate appearance lies an incredible feat of biological engineering. To survive the erratic temperatures of early spring, where a sunny afternoon can be followed by a night of bone-chilling frost, the snowdrop produces its own natural antifreeze. These are specialized proteins that circulate within the plant's cells, inhibiting the growth of ice crystals. In most plants, a hard freeze causes the water inside the cells to exudate into jagged shards, piercing the cell walls and causing the plant to collapse. But the snowdrop's proteins act like tiny, soft shields, keeping the ice crystals small and harmless. It is a quiet, internal resilience, a way of saying to the lingering cold that life will not be deterred. As you listen to the story of the snowdrop, imagine the steady persistence required for such a small thing to emerge. The tip of the plant's first leaf is reinforced, acting like a tiny green spearhead. With agonizing slowness, it pushes upward through the compacted, half-frozen soil, nudging aside pebbles and heavy waterlogged leaves. It is a journey of mere inches, yet it represents a monumental victory of life over the stillness of winter. When the flower finally bows its head and opens its three outer petals, it reveals a hidden sanctuary within, a single glistening drop of nectar. In the stillness of the early spring meadow, this nectar is more than just a sweet liquid. It is a high-energy fuel, a vital lifeline offered to the world's earliest residents. The air is still crisp, and the wind may still carry the scent of distant snow, but the presence of the snowdrop is a signal. It is a beacon of sugar and hydration in a landscape that has been dry and dormant for months. This first drop of nectar is a reward for those who have managed to survive the long dark, and it is specifically designed to attract the very first visitors of the season. Take a slow, deep breath and visualize that small, white, bell-shaped flower nodding gently in the cool breeze. It stands alone for now, a solitary light in the brown and gray meadow, waiting for the arrival of someone who has been sleeping for a very long time. Somewhere nearby, tucked into a hole in the earth or a crevice in an old stone wall, a heartbeat is beginning to quicken. A life is stirring, sensing the subtle shift in the earth's temperature and the unmistakable calling of the first bloom. The meadow is no longer just a place of rest. It is becoming a place of discovery once again. Imagine a small hidden chamber lined with dry moss and tucked safely beneath the roots of an old gnarled oak tree. In this dark, quiet space, a single life has been waiting for the world to turn. This is the queen bumblebee, and she had been in a state of deep, suspended animation since the first frost of last autumn. While we slept through the winter, she remained perfectly still, her heartbeat slowed to a mere ghost of a rhythm, her body protected by natural compounds that prevented her delicate tissues from freezing. She is a solitary survivor, a true queen in every sense of the word, unlike honeybees who spend the winter huddling together in a great warm cluster to keep their queen alive. The bumblebee queen faces the cold entirely alone. Her sisters, the workers, and the old queen from her birth colony all perished months ago as the flowers faded and the days grew short. She carries within her the entire future of her kind, the potential for hundreds of new bees that will one day hum through the summer air. But for now, she is simply a cold, heavy body beginning to respond to the subtle warmth of the rising sun. As she stirs, she faces a significant challenge. The air in the meadow is still quite cool, often far below the temperature required for an insect's muscles to function. To take flight, her internal temperature must reach nearly 30 degrees Celsius or 86 degrees Fahrenheit. To achieve this, she performs a quiet miracle of biology known as thermogenesis. She uncouples her wings from her flight muscles, allowing her to vibrate those massive muscles at incredible speeds without actually moving her wings. It is a deep internal shivering. If you were standing very close to her mossy doorway, you might hear a faint, low-frequency hum, the sound of a tiny engine warming up. This shivering generates heat, slowly raising her body temperature until she is warm enough to crawl out into the light. Her first steps onto the damp earth are slow and deliberate. Her fuzzy black and yellow coat, thick as a winter sweater, traps the heat she has worked so hard to create. She takes to the air with a heavy, low-altitude buzz. Her flight is not the darting, erratic path of a summer fly, but a purposeful, searching patrol. She flies just inches above the ground, weaving through the dry stalks of last year's grass. She is searching for a very specific kind of treasure, a nesting site. She looks for the abandoned burrows of field mice or small cavities beneath stones, somewhere dry, dark, and safe where she can begin the laborious task of building a new colony from scratch. However, this search requires an enormous amount of energy. Every second she spends vibrating her muscles and flying through the cool air drains her limited reserves. Her survival and the survival of the colony she hopes to start depends entirely on finding a source of high-energy fuel. This is where the story of the bee and the flower become one. As she navigates the brown landscape, her sensitive antennae pick up a familiar scent, and her large eyes catch a glimmer of white against the earth. It is the snowdrop we encountered earlier, nodding its head in the breeze. For the queen, this flower is not just a beautiful sight, it is a vital refueling station. The nectar, hidden deep within the snowdrop's bell, is a concentrated burst of sugar, exactly what she needs to keep her internal engine running. As she lands on the delicate white petals, her weight causes the flower to sway gently. This is the beginning of a profound partnership. As she reaches deep into the bloom for her reward, tiny grains of pollen, the flower's own genetic legacy, cling to the soft hairs of her body. When she moves on to the next snowdrop, she will carry that pollen with her, ensuring the flower can create seeds for the following year. The bee's need for energy and the flower's need for a messenger are perfectly aligned. This interaction is the first stitch in the complex tapestry of the meadow's life, a delicate dance of survival that has repeated for millions of years. As you imagine the queen bumblebee resting for a moment on that white petal, feel the steady rhythmic pulse of life returning to the world. The meadow is waking up, one heartbeat and one blossom at a time. To understand how this partnership works so perfectly, we must look closer at the flower itself, which is far more than just a source of food. If we were to look very closely at the blossom, where our queen is resting, we would see a masterpiece of biological engineering. Each wildflower is a quiet miracle of architecture, designed over millions of years with a specific purpose in mind. To our eyes, a flower is a symbol of beauty, but to the meadow, it is a sophisticated machine built for the continuation of life. Before the flower even opens, it is protected by the sepals. These are the small green leaf-like structures that wrap around the delicate bud like a protective shell or a warm blanket, shielding the tender colors inside from the late winter frost and the nibbling of hungry insects. As the sun warms the air, these sepals peel back, often remaining at the base of the flower like a sturdy foundation, allowing the petals to unfurl. The petals are the vibrant banners of the plant world, designed to catch the eye and signal that a reward is waiting within. But the true heart of the flower lies deeper, in the parts that do the quiet work of creation. There you find the stamen, the slender, delicate stalks that produce the golden dust we know as pollen. Each grain of pollen is a tiny vessel of genetic information, waiting for a courier. At the center of these stamens stands the pistil, the elegant, often vase-shaped structure that leads down to the ovary. This is where the magic of fertilization happens, where the pollen must eventually travel to transform the flower into a seed. As you breathe in slowly, imagine the soothing sense of balance found in these designs. Nature often organizes these parts with a mathematical grace. Many flowers, like the simple daisy or the wild rose, have what scientists call radial symmetry. They are shaped like a sun or a star, perfect circles that look the same from every angle. These flowers are generalists. They can be approached by a pollinator from any direction, offering an open invitation to anyone who passes by. Others, however, possess bilateral symmetry, meaning they have a distinct left and right side, much like a human face or the wings of a butterfly. This is a more specialized form of engineering. In flowers like the violet or the snapdragon, the petals are arranged in a specific way to guide the visitor. Often the lower petal is larger and flatter than the others, evolving into a physical landing pad. It is a sturdy living platform designed specifically to support the weight of an insect, acting like a welcoming porch that ensures the bee is in the perfect position to reach the nectar. As the bee touches down on this living runway, the flower's architecture gently steers her body as she reaches for the sweet nectar hidden in the flower's deep wells. She inadvertently brushes against the pollen-laden stamen, or perhaps she leaves behind pollen from a previous stop on the sticky tip of the pistil. It is a seamless, silent exchange of gifts. One provides the fuel for flight, the other ensures the future of the meadow. Every curve and every line of the flower is there for a reason, a quiet map leading the way to a hidden treasure. But how does a bee, flying through the vastness of a sun-drenched meadow, know exactly which flower to choose? How does she recognize these landing pads and intricate designs from a distance? To find the answer, we must look through eyes very different from our own, into a world of light and color that is invisible to the human gaze. Imagine for a moment that the world around you is draped in a light you have never seen before. While our human eyes are limited to a specific range of colors, the familiar rainbow from red to violet, the bee lives in a reality that extends far beyond our own. They possess a gift called ultraviolet vision, a way of seeing that transforms a simple meadow into a landscape of glowing maps and secret messages. To a bee, the color red is often a quiet, dark shadow, almost invisible against the green of the surrounding leaves. But as they move toward the blues, the yellows, and the violets, the world begins to shimmer with a new kind of intensity. They see a color we sometimes call bee purple, a vibrant mix of yellow and ultraviolet light that stands out like a beacon against the landscape. As you rest your head and let your eyes close, try to visualize this hidden world. Think of a wildflower you might find in a sun-drenched field. To you, its petals might seem like a single, solid shade of primrose or lavender, but as the bee approaches, she sees something entirely different. Deep within the petals, there are patterns, lines, spots, and streaks that act as nectar guides. To the bee, these patterns are like the glowing lights of a landing strip at an airport, pulsing with information. They are not random, they are a direct conversation between the plant and the pollinator, a silent set of instructions that says, follow these lines to find the sweetness you need. These guides are often invisible to us, tucked away in the ultraviolet spectrum, yet they are the primary reason the bee can navigate so effortlessly from bloom to bloom. It is a beautiful, symbiotic design. The flower wants to be found, and the bee needs to find it. This visual dialogue is most striking in the flowers we see every day. Consider the humble dandelion, that bright yellow star of the grass. To our eyes, it is a uniform disk of judkins. But through the eyes of a bee, the dandelion transforms into a perfect bullseye. The outer petals reflect the sun's ultraviolet rays, creating a bright, luminous halo, while the center of the flower absorbs that light and appearing as a dark, inviting well. This high contrast target is impossible to miss. A literal X marks the spot in the middle of a green sea. This secret map doesn't just help the bee find food, it helps her conserve energy, allowing her to move with a calm, rhythmic purpose. She doesn't have to search. She simply follows the light. As she glides through the air, the meadow isn't just a collection of plants, but a vast network of signals, each one calling out to her in a language of color and shape. As the bee draws closer to one of these glowing targets, the visual world begins to soften, and a new sense takes over. The air in the meadow is never truly still. It is filled with invisible currents, carrying messages that sight alone cannot capture. Even as she follows the ultraviolet runway toward the heart of the flower, she begins to pick up on a different kind of signal, a fragrant trail that lingers in the warmth of the morning air. It is a transition from the world of light to the world of chemistry, where every petal exhales a unique story into the breeze. This invisible language of scent is just as complex as the colors we see, and it is the next guide on our journey through the meadow. As the bee drifts closer, the visual world of ultraviolet patterns begins to merge with a world of invisible chemistry. Every flower in this meadow is a tiny laboratory, a master of a language we can only partially understand through our own sense of smell. To us, a rose or a clover might simply smell sweet. But to the bee, it is a complex, data-rich map of volatile organic compounds, or voci. These are the molecules responsible for the fragrance of the meadow, and they are called volatile because they are designed to evaporate easily, turning from a liquid oil on the petal into a gas that can travel through the air. Imagine these molecules as tiny, invisible messengers, floating like microscopic dust motes on the gentle morning breeze. They are not released at random. A flower is a highly efficient organism that manages its energy with great care. Producing these fragrant compounds takes effort, so the plant times their release with incredible precision. A flower that relies on bees will exhale its strongest scent in the warmth of the morning and early afternoon, exactly when the sun has warmed the air enough for the bees to fly. In contrast, flowers that wait for the silver light of the moon to attract moths will remain almost scentless all day, saving their aromatic treasures until the sun dips below the horizon. This biological clock ensures that the invitation is sent only when the guest is likely to arrive. On a still, quiet morning, these scents don't just dissipate into a cloud. They form what scientists call a scent plume. Think of it like a ribbon of silk stretching out from the center of the flower, undulating and twisting through the grass. The bee is exquisitely sensitive to these chemical ribbons, using her antennae, which are covered in thousands of tiny sensory organs. She can detect a single molecule of fragrance among millions of molecules of air. She doesn't just smell the flower, she tracks it. By moving her head from side to side, she can feel the edges of the scent trail, steering herself back toward the center whenever the fragrance begins to fade. It is a form of navigation as steady and rhythmic as a deep, slow breath. As you lie there, imagine the air around you filled with these gentle, invisible trails. Each one is unique. Some are bright and citrusy, others are soft and earthy like honey and warm hay. They cross and overlap in the cool air, creating a tapestry of information that guides the bee through the tall stalks of grass. She is no longer just flying. She is being pulled toward her destination by a chemical tether. The closer she gets, the more intense the fragrance becomes. It is no longer a distant hint, but a focused, powerful signal that confirms she has found exactly what she was looking for. The scent tells her not only the species of the flower, but also how much nectar it might be holding. It is a promise of a reward, a biological contract signed in perfume. She is now only inches away from the petal's edge. The ultraviolet bullseye is clear before her eyes, and the fragrance is a steady hum in her senses. Now, the dance changes. She must transition from the broad, sweeping movements of travel to the delicate, high-precision maneuvers of landing. To do this, she relies on a feat of biological engineering that seems to defy the very laws of physics. As she prepares to touch down on the swaying platform of a wildflower, the soft, rhythmic sound of her wings becomes the heartbeat of the meadow, a steady vibration that carries her toward the final, gentle contact between insect and bloom. For a long time, there was a popular myth that, according to the laws of physics, a bumblebee shouldn't be able to fly. To the early observers of aerodynamics, her body seemed too heavy and her wings too small and fragile to provide enough lift. But nature does not follow the simplified models of our past. It operates on a level of complexity that is as beautiful as it is efficient. The secret to the bee's flight lies not in the size of her wings, but in the extraordinary way she moves them. Unlike a bird, which uses long, sweeping strokes to push against the air, the bee uses a much more sophisticated technique. Her wings move in a short, rapid arc, roughly 90 degrees, and they flip over as they reach the end of each stroke. It is less like the flapping of a bird and much more like the spinning rotors of a tiny organic helicopter. This rapid back and forth twisting creates little whirlwinds or vortices in the air above her wings. These tiny cyclones create a pocket of low pressure that literally pulls the bee upward, providing the lift she needs to carry her fuzzy pollen-heavy weight through the meadow. She performs this feat with incredible speed. Her wings beat approximately 230 times every single second. This isn't a conscious, tiring effort in the way we might think of exercise. It is a high-frequency vibration that resonates through her entire thorax. This is the source of that iconic, low-frequency hum we hear on a summer afternoon. It isn't the sound of a voice. It is the sound of physics in action, a steady, rhythmic pulse that signifies the very presence of life in the grass. As you lie there, let that sound settle into your mind, a steady, low, soothing vibration. Imagine it as a soft, golden light that pulses in time with your own heart. Try to match your breathing to this steady, natural pace. Take a slow, deep breath in, imagining the bee hovering perfectly still in the air, and then a long, soft exhale as she stabilizes herself against a gentle breeze. Feel the vibration as a calming frequency that clears away the busy thoughts of the day, leaving only the quiet, focused energy of the meadow. There is no rush here. There is only the rhythm of the air and the steady, purposeful movement of the wings. She is hovering now just a fraction of an inch from the petal of a wildflower. The flower sways slightly in the morning air, a moving target, but the bee's flight is so precise that she moves in perfect synchronization with the bloom. She is no longer fighting the air. She is part of it. Her legs, covered in fine, sensitive hairs, reach out to touch the surface. The tiny claws at the ends of her feet find purchase on the microscopic ridges of the petal, ridges that are invisible to us, but which feel like a sturdy, welcoming staircase to her. This is the moment where the air meets the earth. The high-speed vibration of her wings begins to slow. The hum drops in pitch, becoming a soft, contented purr as she folds those transparent wings neatly against her back. The tension of flight is gone, replaced by the solid, tactile reality of the flower beneath her. She has arrived at her destination, and as she settles her weight onto the bloom, a strange and silent force begins to act between them, a hidden energy that has been building since the moment she first took flight. As the bee settles onto the petal, something invisible and quite remarkable begins to happen. It is a silent dialogue written in the language of physics, a spark without a flame, a tiny pull that governs the relationship between the flyer and the flower. This is the world of electrostatic attraction, a hidden force that ensures the meadow's survival without either party having to lift a finger. During her flight through the morning air, the bumblebee has been busy in ways we cannot see. As her wings beat rapidly and her fuzzy body brushes against air molecules, she builds up a positive electrical charge. It is a subtle, natural buildup of static electricity, much like the gentle crackle you might feel when touching a soft wool blanket on a dry winter night. By the time she reaches the flower, she is buzzing with this invisible energy, a tiny, living battery of positive ions. The flower, meanwhile, remains rooted deep in the cool, damp earth. Because it is physically connected to the ground, it maintains a negative electrical charge. In the quiet physics of the meadow, these two opposites, the wandering bee and the stationary bloom, are drawn together by a force as fundamental as gravity. This difference in charge creates a localized electric field, a secret signal that tells the bee the flower is ready for her, and tells the flower that a visitor has arrived. The payoff of this connection is nothing short of magical. Even before the bee's legs fully grasp the center of the bloom, the gap between them is bridged. The tiny, microscopic grains of pollen, the flower's golden dust, feel the irresistible pull of the bee's positive charge. They do not wait to be brushed off or accidentally moved. They actually leap. They fly through the air across that tiny, infinitesimal space, jumping from the flower's anthers and clinging tightly to the bee's velvet soft fur. Imagine thousands of these tiny golden sparks of life dancing through the air to find a home in the bee's coat. It is an effortless harvest. The bee doesn't have to struggle to collect every grain. Her very presence, the result of her journey through the sky, makes her a living magnet for the meadow's future. The pollen grains are evolved for this. Many have tiny hooks or sticky coatings, but it is the electrostatic pull that provides the initial, decisive invitation to hitch a ride. As you lie there, let the image of this silent, effortless attraction soothe your mind. Think of your own body now, resting heavily and peacefully against the mattress. Just as the bee and the flower share this quiet, natural exchange of energy, feel the gentle exchange of your own breath with the cool air around you. There is no effort required in this moment. You are simply part of the room, part of the night, grounded and still, just like the flower in the soil. You are exactly where you needed to be, supported by the world around you. Now, the bee is covered. She is a golden ghost, dusted from her head to her thorax in the life-giving powder of the bloom. She is heavy with the potential of 1,000 new seeds. But she cannot fly long with such a chaotic, loose coating of dust. This hitchhiking pollen is precious, but it is also messy, and she must be efficient. As she sits in the heart of the flower, she begins a slow, rhythmic dance of grooming, a meticulous process of tidying her treasures and packing them away for the journey home. As the bee rests in the cradle of the petals, she begins a movement as old as the meadow itself. Her legs move with a rhythmic, mechanical grace, sweeping over her fuzzy body. Imagine her legs as tiny, delicate brushes, each one equipped with stiff, specialized hairs called pollen combs. With slow, deliberate strokes, she combs through the golden dust that has settled on her head and thorax, gathering the grains and moving them downward. She is a master of efficiency, wasting nothing. To make the dry dust easier to manage, she mixes it with a tiny drop of nectar, creating a sticky, malleable paste. This paste is then packed into a remarkable structure on her hind legs, known as the corbicula, or the pollen basket. This isn't just a metaphor. The corbicula is a smooth, concave area of the leg framed by long, stiff hairs that curve inward like the ribs of a basket. As she works, the golden pellets grow larger and rounder, glowing like bright yellow jewels against her dark fur. These baskets allow her to carry a heavy load, sometimes up to half her own body weight, back to her nest without losing a single grain to the wind. While we often think of nectar as the bee's primary goal, the pollen is just as vital. If nectar is the fuel that powers her flight, but pollen is the building block of life. It is a biological powerhouse packed with concentrated proteins, essential fats, minerals, and vitamins. For the developing larvae waiting in the nest, this bee bread is the only source of protein they will ever know. It is the foundation upon which the next generation of the meadow's guardians is built. In this quiet exchange, we see the perfect balance of nature. The flower is not merely being robbed of its dust. It is paying a price for a service. By offering this high-protein gift, the flower ensures the bee will visit, and in doing so, the bee becomes an unwitting courier. As she moves from one bloom to the next, some of those grains will inevitably fall, finding their way to the heart of another flower, beginning the process of creating a seed. It is a beautiful, silent contract, a mutual benefit where both parties thrive, and the meadow continues its cycle of growth. As you breathe in and out, think of this harmony. Everything in the meadow has a role, a purpose, and a partner. You, too, are part of a larger rhythm. Just as the bee finds her reward in the flower, your body finds its reward in this stillness, gathering the rest it needs to flourish tomorrow. Feel the weight of your limbs, as settled and purposeful as the bee in her moment of rest. But the bumblebee is not the only traveler in this early spring landscape. While she is busy packing her golden baskets, other wings are beginning to catch the light. Higher up, near the rough bark of the ancient trees that fringe the meadow, a different kind of awakening is taking place. A shadow stirs against the dark wood, unfolding with a slow, heavy rhythm that matches the heartbeat of the waking earth. There are others who have waited all winter for this moment, hidden in plain sight. While the bumblebee's hum fills the low air near the blossoms, look up toward the edge of the woods where the meadow meets the trees. There, clinging to the rough gray bark of a willow or an elm, is a creature that seems to have materialized from the shadows themselves. This is the morning cloak butterfly, one of the first true signs that the season has turned. Unlike most butterflies that spend the winter as tiny eggs or hidden pupae, the morning cloak does something extraordinary. It survives the freezing months as a fully formed adult. Imagine this delicate creature tucked into a deep crevice of tree bark, shielded only by the folded canopy of its own wings. Its undersides are dark and mottled, mimicking the texture of burnt wood or dried leaves, making it nearly invisible to hungry birds or the wandering eyes of predators. It has spent the last several months in a state of deep dormancy, its metabolism slowing to a near halt, waiting with a quiet patience for the first consistent warmth of the year. When the sun finally touches the bark with enough strength to seep through the layers of wood, the morning cloak begins its slow, silent awakening. As it moves from its winter crevice, it seeks out a patch of direct sunlight. Here, we see the brilliance of its biological design. The upper side of its wings is a deep velvety maroon, almost black, bordered by a row of bright iridescent blue spots and a soft, creamy yellow edge. These dark colors are not just for display. They function as biological solar panels. Dark pigments are incredibly efficient at absorbing solar radiation, pulling the sun's warmth directly into the butterfly's body. Because the spring air is still crisp and the ground may still hold the memory of frost, the morning cloak must harvest every bit of heat it can to power its flight muscles. Watch as it rests on a sun-drenched log or a patch of bare earth. It slowly opens its wings, then closes them, open and close. This rhythmic motion is a deliberate act of recharging. Each time the wings spread, the dark surface area increases, soaking up the light and converting it into the energy needed for movement. It is a slow, meditative pulse, a heartbeat you can see. You might find your own breathing matching this gentle pace. Inhale as the wings spread wide to catch the gold of the sun. Exhale as they fold back together in a moment of rest. There is no rush in this process. The butterfly knows that the warmth is coming, and it has all the time it needs to sit in the stillness and prepare. This solitary awakening of the morning cloak marks the end of the early, quiet days of the season. Soon, the landscape will no longer be a collection of brave individuals. The lone bee, the single snowdrop, the solitary butterfly. We are moving steadily into the great, vibrant rush of mid-spring, where the diversity of the meadow begins to explode in 1,000 different directions. The ground is softening further. The air is thickening with a tapestry of new scents. And the interactions between the living things here are becoming more complex and wonderful. New colors are appearing right at our feet, hidden among the blades of grass, and with them come new stories of survival and partnership that happen just inches above the soil. Among these new arrivals are small, vibrant blossoms that don't look to the sky for help, but rather to the busy world beneath them. Look down now, away from the soaring butterfly and the buzzing bees, toward the very edge of the grass. There, nestled low against the cool earth, are the violets. Their deep purple petals look like velvet, soft and inviting, nodding gently in the slight breeze, while the flowers above them reach for the sky. The true story of the violet's future is happening right on the ground, in a partnership that is as ancient as it is quiet. It is a relationship between a flower and a creature we often overlook, the ant. In the world of botany, there is a beautiful term for this, myrmecocuri. It simply means seed dispersal by ants. While many plants spend their energy trying to attract creatures with wings to carry their legacy far and wide, the violet has chosen a different path. It relies on a crawler rather than a flyer. When the violet's flowers eventually fade and the seed pods ripen and burst, they don't just drop their seeds and hope for the best. Each seed is equipped with a tiny specialized gift called an eleosum. An eleosum is a small, fleshy structure attached to the seed, rich in fats and proteins. To an ant, this is a prize of immense value. Imagine a tiny ant moving rhythmically through the forest of grass blades, discovering one of these seeds. It doesn't see the seed as a plant. It sees the eleosum as a high-energy feast for its colony. The ant grips the seed carefully and begins the long journey back to its underground home. As you lie there, imagine the steady, determined pace of the ant navigating the miniature valleys and hills of the soil. It carries the seed down into the safety of the nest, deep underground. Once inside, the ants consume only the fatty eleosum, leaving the seed itself completely unharmed. Because the seed is hard and smooth, the ants cannot eat it, so they do what any tidy gardener would do. They carry the trash to their waste chambers. But for the violet, this waste chamber is actually a luxury nursery. These underground rooms are filled with rich organic matter, protected from the biting frost of late spring and the hungry eyes of birds. The ant has effectively planted the violet seed in perfectly fertilized soil, deep enough to be safe, but shallow enough to feel the warmth of the sun as it penetrates the earth. It is a silent, subterranean choreography that ensures the meadow remains carpeted in purple year after year. It is fascinating to think of a flower that has evolved such a specific, grounded strategy. While the rest of the meadow is busy shouting for the attention of the wind or the bees, the violet waits in the stillness for the touch of a tiny foot. This reminds us that in nature, there is no single right way to grow. There is a place for the high flyers and a place for those who keep their secrets close to the dirt. This deep connection between the plant and the ant is only possible because of the incredible health of the soil itself. The ground beneath the meadow is not just a solid mass. It is a living, breathing landscape of its own. As the violet seeds settle into their new underground homes, they are entering a world of immense complexity. Beneath the surface, the soil is humming with a different kind of energy, a hidden infrastructure that supports every blade of grass and every petal we see. The health of the violet, the strength of the ant, and the beauty of the meadow all depend on the dark, rich world that exists just out of sight, where the roots and the earth become one. Beneath the meadow's surface, where the violet seeds are tucked away by the ants, there exists a hidden architecture so vast and intricate it challenges our understanding of the natural world. This is often called the wood wide web, a living, pulsing network of mycorrhizal fungi that weaves through the soil like a delicate silver lace. While we admire the flowers and the bees above, a silent, sophisticated conversation is happening right under our feet. These fungi form a symbiotic relationship with almost 90% of all land plants, creating a bridge between individual roots that can span the entire length of the meadow. The word mycorrhiza comes from the Greek words for fungus and root, and it describes a partnership based on mutual care. The plants, through the miracle of photosynthesis, create energy in the form of sugar. They share this sweetness with the fungi, which cannot produce their own food. In exchange, the fungi act as a massive extension of the plant's root system. Their tiny thread-like filaments, called hyphae, are much thinner than even the smallest root hair, allowing them to reach into microscopic crevices in the soil to find water and essential minerals like phosphorus and nitrogen that the plant could never reach on its own. But this network is more than just a trading post for nutrients. It is a communication system. Through these fungal threads, plants actually talk to one another. If a plant on one side of the meadow is being nibbled by a caterpillar, it can send chemical signals through the network to warn its neighbors. These neighboring plants, receiving the message, can then begin to produce bitter chemicals in their leaves to protect themselves before the caterpillar even arrives. It is a community of constant quiet support. Sometimes older, more established mother plants will even use the network to send extra sugar to smaller, shaded seedlings that are struggling to find enough light. As you think of this vast interconnected web, let yourself settle deeper into the stillness. Imagine your own body as a part of this peaceful system. Feel the weight of your shoulders, your hips, and your legs grounding you into the bed, much like a root settling into the cool, dark earth. There is a profound safety in being part of something so large and so supportive. You don't have to hold yourself up. The earth and the bed beneath you are doing all the work. Take a slow, deep breath, and as you exhale, imagine any tension leaving you, traveling down into the ground where it is absorbed and recycled by the cycle of life. This healthy, interconnected soil is the foundation for everything that follows. Because the plants are so well nourished and protected by their fungal partners, they can produce the high-quality nectar and pollen that the meadow's residents rely on. And as the morning sun begins to warm the air, the first of these residents begin to appear. They aren't the large social honeybees we often think of, but a different, more solitary group of workers. These are the solitary bees, the quiet individuals who go about their work without the fanfare of a hive, each one a tiny, focused miracle of nature, ready to begin their part in the meadow's grand design. Among these solitary workers, one of the most diligent and gentle is the mason bee. Unlike the honeybees we often imagine, living in crowded, buzzing cities of wax, the mason bee is a creature of quiet independence. She has no queen to serve and no hive to protect. Because she has no honey stores to defend, she is remarkably non-aggressive, moving through the meadow with a singular purpose. She is often a beautiful, dark metallic blue or black, glinting like a small moving jewel in the soft morning light. Her name comes from her incredible skill as a builder. She does not dig her own tunnels. Instead, she seeks out small, pre-existing cavities, perhaps a hollow plant stem, a dry reed, or a hole left behind by a wood-boring beetle. Once she finds the perfect spot, she begins her work as a master architect. She flies to a nearby patch of damp earth, gathering a tiny ball of mud in her jaws. She carries this back to her chosen tunnel to create a sturdy wall at the very back. This is the first room of her nursery. Inside this room, she places a pollen loaf, a concentrated mixture of nectar and pollen she has carefully gathered from the early spring blooms. On top of this feast, she lays a single egg. Then she returns to the mud source, bringing back more material to build a second wall, sealing the first chamber and creating the foundation for the next. She repeats this process until the tube is filled with a series of neat mud-walled rooms, each containing a future bee and enough food to help it grow. What makes the mason bee so vital to the meadow is her extraordinary efficiency. While a honeybee is a very tidy worker, carefully grooming pollen into the organized baskets on her legs, the mason bee is much more casual. Her belly is covered in stiff, coarse hairs called scopa. As she moves from flower to flower, pollen sticks to these hairs in a disorganized scramble. Because the pollen is kept loose and dry on her underside, it falls off easily onto the next flower she visits. This messy method makes her a powerhouse of pollination. In fact, a single female mason bee can often visit as many flowers and transfer as much pollen as nearly 80 to 100 honeybees. She is a quiet hero of the meadow, ensuring that the seeds of the next generation are sown with every clumsy, pollen-dusted landing. Once her work is done and the tube is sealed with a final thick plug of mud, the mother bee's life cycle comes to a gentle close. But her legacy remains safe behind those earthen walls. Inside the dark, cool chambers, the eggs hatch into tiny larvae. They eat their pollen loaves, grow strong, and eventually spin a silk cocoon. There, they will rest through the coming months, waiting for the precise moment when the earth warms again to chew their way through the mud and begin the cycle anew. As we watch these solitary builders finish their morning tasks, the character of the meadow begins to change. The long shadows of the early hours are retreating, and the air is losing its crisp spring edge. The sun climbs higher in the sky, its light turning from a pale silvery yellow to a deep golden warmth. We are moving out of the gentle awakening of spring and into the vibrant, humming energy of early summer. The meadow is preparing for its most intense period of growth, where the light is strongest and the days seem to stretch on forever, inviting a new rhythm to the life within the grass. The sun has now reached its highest point in the sky, casting short, dark shadows directly beneath the tall stems of the grasses. The pale morning light has deepened into a rich, shimmering gold, and for a moment, the meadow seems to hold its breath. A peculiar hush falls over the landscape. This is the midday lull, a period of quiet observation that many living things in the meadow instinctively follow when the heat is at its most intense. If you were to walk through the meadow now, you might notice that it feels different than it did just a few hours ago. The frantic activity of the early morning has softened into a slower, more deliberate rhythm. In this stillness, the plants themselves are making subtle, calculated adjustments. For a wildflower, nectar is a precious commodity, a carefully balanced recipe of sugars and water designed to attract the right visitors. But in the direct overhead heat of high noon, this liquid gold is at risk. If the sun's rays are too intense, the water in the nectar can evaporate, leaving behind a sticky, crystallized residue that is difficult for insects to drink. To protect this investment, many flowers have evolved a clever strategy of temporary retreat. Consider the common daisy, known scientifically as Bellis perennis. Its name is derived from the Old English day's eye, a tribute to its habit of opening its white ray florets with the rising sun and closing them as the day ends. However, the daisy is also sensitive to the intensity of the midday sun. It practices a biological movement called nyctinasty. While we typically think of this as a sleep movement that happens at night, it is actually a response to environmental cues like light and temperature. Inside the base of the daisy's petals, specialized cells respond to the heat by expanding and contracting. This isn't a simple mechanical folding. It is a slow, graceful growth process. Cells on the underside of the petal grow slightly faster than those on the top, causing the petal to curve upward and inward. By drawing its petals together during the peak of the heat, the daisy protects its central yellow disc, the place where the actual pollen and nectar reside. It creates a tiny, sheltered microclimate, keeping the air inside its petals just a few degrees cooler and significantly more humid than the air outside. As you lie here, imagine the meadow around you doing the same, softly folding inward, conserving its energy, and waiting for the air to soften. The daisy is a symbol of resilience, standing low in the grass, unbothered by the sun that might wilt more delicate blooms. It is a patient survivor, perfectly synchronized with the movement of the earth and the heat of the sky. As the daisy tucks itself away for a midday rest, it waits for the temperature to dip just enough for the pollinators to return in force. Yet, even in this quiet hour, the meadow is never truly empty. There is a sound, beginning as a distant vibration and growing into a steady rhythmic thrum. It is the sound of a highly organized society, one that does not stop for the heat, but rather works in harmony with it. Emerging from the tall grass, a golden brown figure appears, moving with purpose toward the clover. We are about to meet the most famous and complex resident of the meadow, an insect whose life is defined not by the individual, but by the strength of the collective. The honeybee we see landing on the clover is a marvel of individual engineering, but she is also part of something much larger and more profound. A single honeybee is remarkable, but together, tens of thousands of them function as one single, massive living entity, a superorganism. In this collective state, the colony acts with a shared intelligence, almost as if it has its own heartbeat, its own memory, and its own breath. As you lie still, imagine the interior of the hive, a place of constant rhythmic activity. While the temperature in the meadow outside might fluctuate between the cool of the morning and the heavy heat of the afternoon, the heart of the hive remains a steady, comforting 95 degrees Fahrenheit. This precise, consistent warmth is essential for the survival of the next generation. The young larvae tucked away in their hexagonal wax cradles. To maintain this perfect environment, the bees work in a beautiful, silent coordination. When the summer sun beats down too intensely, the bees become master engineers of climate control. They do not just endure the heat, they actively manage it. Specialized water carrier bees fly out to nearby streams or find dew-heavy leaves, bringing back tiny droplets of water to the hive. They spread this water in thin, shimmering films across the edges of the honeycomb. Then, a dedicated line of bees stands at the entrance, their wings blurring into a soft, steady hum. By fanning their wings in perfect unison, they create a cooling draft that draws the warm air out and pulls the moisture-laden air across the cells. This evaporative cooling acts as a natural air conditioning system, a rhythmic cooling breath that keeps their home safe and serene. Within this society, every bee has a role that shifts gracefully with the passing of time, a process scientists call temporal polyethism. It is a life of steady progression. In the first days of her life, a young bee is a quiet housekeeper, cleaning the cells and keeping the hive tidy. As she grows, she becomes a nurse, gently tending to and feeding the larvae. Later, she may help build the intricate silver-gold geometry of the comb or stand as a sentinel at the entrance. Finally, When she is at her strongest and most experienced, she transitions into the role of a forager. This is the stage where she finally leaves the darkness of the hive to venture out into the vast, bright world of the meadow. Each forager is a scout and an explorer, searching for the richest nectar and the most vibrant pollen. But her work is not finished once she finds a floral treasure. Her most important task is to return to the heart of the hive and share her discovery with her sisters. In the dim, fragrant light of the colony, surrounded by the scent of wax and honey, she prepares to tell a story through movement. She is about to translate the geography of the sun and the meadow into a language of rhythm and vibration, ensuring that the bounty of the field is shared by all. The forager bee finds a small, clear space on the vertical wax comb, surrounded by her sisters, who wait in the fragrant dimness. Here, in the heart of the colony, she begins a performance that is as much a feat of mathematics as it is a dance. This is the famous waggle dance, a rhythmic, swaying movement that serves as a sophisticated map for the rest of the hive. In the early 20th century, a patient observer named Carl von Frisch spent years watching these tiny creatures, eventually deciphering this secret language and revealing that bees possess a level of symbolic communication once thought to belong only to humans. It is a quiet, vibrating story told in the dark, and yet it contains the precise coordinates of the entire meadow. Because it is dark inside the hive, the other bees do not watch the dance with their eyes. Instead, they gather close, pressing their sensitive antennae against the dancer to feel the vibrations and the direction of her body. The forager moves in a tight figure-8 pattern. The most vital part of the dance is the waggle run in the middle of the 8, where she shakes her abdomen rapidly from side to side. To communicate direction, she uses the sun as her primary compass. Even though she is deep inside the hive where the sun cannot be seen, she uses the vertical axis of the honeycomb to represent the sun's position in the sky. If she waggles straight upward on the comb, she is telling her sisters to fly directly toward the sun. If she waggles at a 45-degree angle to the right of the vertical, she is telling them to fly out of the hive and keep the sun at a 45-degree angle to their right. The precision of this insect mathematics is breathtaking. The duration of the waggle run tells the watching bees exactly how far they must fly. For every second she spends waggling, she might be describing a distance of about 1 kilometer. A short, energetic burst means the flowers are just over the next rise. A long, drawn-out vibration means a journey to the very edge of their world. She even accounts for the wind speed she encountered on her flight and the shifting position of the sun as time passes. It is a beautiful, shared consciousness, a map made of motion and time pass from one body to another through a gentle, humming touch. As the dance concludes, the message is received with a quiet, collective understanding. A group of bees, now programmed with these invisible coordinates, takes flight from the hive entrance. They stream out into the warm afternoon air, their tiny internal compasses locked onto the path described in the dance. They fly over the tall grasses and the swaying daisies, ignoring the distractions of closer blooms because they are searching for a specific treasure. Today, the map leads them to a lush, shaded bank where the summer sun filters through the trees, illuminating the tall, regal spikes of the foxglove. These towering flowers, with their cascades of bell-shaped blooms represent the next chapter in the meadow's great summer diversity, waiting for the perfect visitor to unlock their hidden sweetness. Imagine these tall seeks of purple and pink rising from the dappled shade at the edge of the woods. The foxglove is a masterpiece of specialized engineering, a floral lock that requires a very specific key to open. While the meadow is filled with many different insects, the foxglove has a design intended for only a few. Its bell-shaped blooms are hung like heavy lanterns, each one a private chamber designed for a heavy, robust guest. Most often, the bumblebee. As a large, fuzzy bumblebee approaches, she sees the lower lip of the flower, which extends outward like a sturdy landing platform. This platform is often decorated with dark, mottled spots surrounded by white halos. To our eyes, they are beautiful patterns, but to the bee, they are a map. They are nectar guides, pointing the way toward the back of the throat, where the sweet reward is hidden. The foxglove and the bumblebee have grown up together through the long ages of evolution, a process called co-evolution. They have shaped one another's lives. The flower is too narrow for a bird and too deep for a small fly, but for the bumblebee, it is a perfect fit. When the bee lands on that lower lip, her weight is exactly what the flower expects. She crawls inside the tube, her fuzzy body filling the space almost completely. This is where the lock and key mechanism truly shines. As the bee pushes deep into the flower to reach the nectar at the base, her back presses upward against the roof of the floral chamber. Tucked away at the top are the flower's stamens, loaded with golden pollen. Because the bee's body is so perfectly sized for this specific flower, her back acts as a brush. As she moves, the flower's trigger is activated, and a fresh dusting of pollen is gently rubbed onto the fine hairs between her wings, a spot she cannot easily reach to groom herself. When she finished and backs out of the flower, she carries that golden cargo with her. When she enters the next foxglove, she will brush against the female part of the flower, the pistil, which is positioned in the exact same spot. The key has found its next lock, and the cycle of life continues with incredible precision. It is a quiet, rhythmic partnership, a slow dance performed 1,000 times a day in the summer heat. Feel the steady, heavy presence of that partnership. Just as the foxglove provides a safe, sheltered space for the bee to work, your own space is a sanctuary for rest. The world outside is complex and intricately designed, but here, in the stillness, everything is balanced and at peace. While the foxglove and the bee share a very public and colorful relationship, the meadow is also home to much older, quieter stories. Not every pollinator is as bright as a butterfly or as loud as a bee. Deep in the shadows of the larger leaves and hidden within the oldest types of blooms, there are visitors who have been performing this work since the time of the dinosaurs. These are the unseen workers of the meadow, the ancient lineage of beetles, who move with a different kind of purpose through the cooling green world. Let your mind drift back through the long ages of the world to a time before there were bees or butterflies. In that ancient landscape, the work of life was already being done by the beetles. They are often called the mess and soil pollinators, a title that reflects their honest, unhurried, and primitive approach to life. While the bee is a precision instrument, The beetle is a sturdy armored traveler, moving through the green world with a sense of timeless purpose. Scientists believe these insects have been visiting flowers for at least 140 million years, dating all the way back to the Cretaceous period. They are the original partners of the plant kingdom, the pioneers of the relationship between blossom and bug. Because they appeared so long before the evolution of nectar-rich, delicate blooms, they have a very different set of preferences. If you were to lean in close to a flower that caters to beetles, you might not smell the sweet floral perfume we usually associate with a summer garden. Instead, you would find scents that are spicy, like cinnamon or ginger, or perhaps a bit musky and fermented, like overripe fruit. These scents are powerful and heavy, designed to travel through the thick, humid air of the ancient world. The flowers they visit have had to adapt to their guests' somewhat clumsy nature. Consider the magnolia, one of the oldest flowering plants on Earth. A magnolia bloom doesn't have the fragile, paper-thin petals of a poppy or a lily. Instead, its petals are thick, waxy, and remarkably tough. They feel more like soft leather or heavy parchment than silk. This is a brilliant piece of biological engineering. Beetles aren't delicate diners. They are mess and soil pollinators because they don't just sip nectar. They often chew on the flower parts as they move. They crawl over the center of the bloom, their heavy hooked legs and sturdy bodies dusting themselves in pollen as they eat. The magnolia's thick petals are designed to survive this munch and stroll method, protecting the flower's reproductive organs while the beetle goes about its business. There is something very grounding about the beetle's work. It is slow, it is deliberate, it is a relationship that has survived the rise and fall of countless species, a steady pulse of life that continues even now in the quiet corners of the meadow. As you lie there, imagine that same sense of ancient, steady rhythm within yourself. Your breath is a cycle that has been with you since your first moment, a constant, reliable presence that requires no effort at all. Just like the beetle resting in the heart of the magnolia, you are held, supported, and safe in this moment of stillness. The heavy heat of the afternoon is beginning to lift now. The shadows under the tall grasses are lengthening, stretching out like long, cool fingers across the earth. The busy, high-pitched buzz of the daytime insects is starting to fade into a gentle, lower-frequency hum, a sign that the meadow is preparing for its first major transition of the day. The bright, direct light of the sun is mellowing into a soft, golden amber, the kind of light that makes the edges of every leaf and stem look fuzzy and warm. The beetles are settling deep into the folds of their thick-petaled sanctuaries, their ancient work for the day largely complete. But as the world begins to cool and the first hints of twilight touch the horizon, the meadow doesn't simply go to sleep. Instead, it shifts its focus. The daytime flowers are starting to tuck their petals away, closing their doors to the sun, but others are just now beginning to wake up. These are the flowers of the dusk, waiting for the moon to take its place in the sky. The air is growing still, and the scent of the meadow is changing, becoming cooler, fresher, and filled with the quiet promise of the night ahead. As the sun dips below the horizon, a new cast of characters begins to stir in the deepening blue of the meadow. While the daisies and clovers fold their petals for the night, the evening primrose is just starting its day. If you were standing in the meadow right now, you might actually see it happen. Unlike most flowers that open slowly over many hours, the evening primrose can unfurl its pale lemon yellow petals in a matter of minutes, right before your eyes. It is a quiet, rhythmic motion, like a slow motion burst of light in the cooling air. These flowers are part of a special group called vespertine plants, those that bloom at twilight or during the night. They don't need the bright, flashy colors of the daytime flowers because their visitors don't rely on sight in the same way. Instead, the evening primrose glows softly in the moonlight, its pale surface acting like a beacon. To a night-flying insect, these white and yellow blooms stand out against the dark foliage like tiny grounded stars. They also release a much more powerful fragrance at night than they do during the day. This scent is a chemical map, a trail of volatile organic compounds that drifts through the still night air, guiding pollinators from hundreds of yards away. And then, out of the shadows, comes the sphinx moth. You might mistake it for a hummingbird at first because of the way it hovers with incredible precision, its wings moving so fast they become a blur. But the sphinx moth is a creature of the night, a master of the dusk. It possesses one of the most remarkable tools in the natural world, a proboscis, or tongue, that can be several inches long, sometimes even longer than the moth's entire body. When the moth finds an evening primrose, it doesn't need to land. It hovers steadily, unfurling that long, delicate straw and guiding it deep into the flower's nectar tube. It is a feat of incredible biological engineering and coordination. The moth drinks its fill of the sweet, energy-rich nectar, and in return, its fuzzy underside brushes against the flower's pollen, carrying it to the next bloom under the cover of darkness. This relationship is so specific that some species of moth and flower have evolved together for millions of years, their shapes perfectly matching like a lock and a key. Take a slow, deep breath now and imagine that cool evening air filling your lungs. The heat of the day has completely evaporated, replaced by a refreshing silver blue stillness. The ground beneath you is releasing the last of its warmth, and the sky above is a vast velvet canopy. Everything in the meadow is softening. The sharp lines of the trees are becoming silhouettes, and the busy sounds of the afternoon have been replaced by the gentle, rhythmic pulse of the crickets. As you settle deeper into your blankets, feel that same sense of quiet transition within yourself. Just as the meadow shifts from the work of the sun to the peace of the moon, your body is shifting too. The day's activities are behind you now. There is nothing left to do but rest and listen to the story of the night. While the sphinx moth is busy at work, most of the meadow's inhabitants are finding their own versions of a bed. We often think of insects as tiny machines that never stop moving, but science tells us a different story. Like us, they have internal clocks, they have rhythms, and as the light fades, they too begin to seek out the safety of sleep. The way an insect sleeps is a fascinating glimpse into the complexity of their tiny lives, a quiet reminder that every living thing needs a moment to pause, to recover, and to experience the stillness of the world. Even the busiest bee must eventually find a place to close its eyes. As you lie there in the stillness, you might wonder, do bees dream? It is a question that invites us to look much closer at the tiny, intricate lives unfolding in the grass. For a long time, we viewed insects as simple creatures of instinct, little biological machines that never truly paused. But modern science has revealed something far more profound. Honeybees, much like us, have distinct sleep cycles. When a bee settles down for the night, its body undergoes a visible transformation. Its antennae, which are usually so alert and constantly twitching to sense the world, begin to droop toward the ground. Its legs relax, its wings settle, and its body temperature actually drops. It enters a state of deep, quiet rest. Researchers have spent years observing these cycles, and what they found is remarkably familiar. When bees are deprived of sleep, they struggle just as we do. You might remember the waggle dance, that extraordinary language of movement bees use to tell their hive mates exactly where to find the best patches of clover or lavender. In fascinating studies, scientists discovered that bees who hadn't had enough rest performed dances that were sloppy and imprecise. They couldn't communicate the coordinates correctly. Their internal compasses were off. They were, in essence, groggy. This tells us that sleep is not just a passive break for them, it is a vital time for their tiny brains to process information, solidify memories, and prepare for the work of the coming day. While the honeybees huddle together in the warmth of the hive, many of the meadow's solitary bees find more poetic places to rest. Imagine, if you can, the soft velvet interior of a flower that has pulled its petals shut for the night. Perhaps a wild rose or a squash blossom. Inside this fragrant, silk-lined chamber, a single bee is tucked away to ensure it doesn't fall out as the wind rocks the flower back and forth. The bee performs a clever trick of biology. It uses its mandibles, its tiny jaws, to grip firmly onto the flower's stamen or a fold of a petal. It locks its jaw into place, allowing its entire body to go limp and hang there in a state of peaceful suspension. In this deep slumber, sheltered from the dew and the moonlight, the bee is safe. It is a beautiful image to hold in your mind, a tiny, fuzzy traveler anchored to the heart of a flower, swaying gently in the night breeze. It is here, in this silence, that the bee's energy is restored. Perhaps, in its own way, it experiences a flicker of what we might call a dream, a lingering sensation of the sun's warmth on its wings, the vibrant ultraviolet glow of a dandelion, or the sweet, heavy scent of nectar. Take a moment now to feel that same sense of heavy, anchored relaxation in your own limbs. Just like the bee tucked inside the petal, you are safe and supported. There is no need to move, no need to plan for tomorrow's dance. You are simply here in the quiet as the meadow prepares for its most magnificent moment. The silver light of the moon eventually begins to pale, giving way to a deep pre-dawn blue. We are moving now toward the peak of the natural calendar, the summer solstice. This is the longest day of the year, the moment when the tilt of the earth brings the sun to its highest, most powerful position in the sky. In the meadow, the solstice is a symphony of light and heat. The shadows are short, and the sun lingers for so long that the earth itself seems to hum with stored energy. This is the height of summer, a time of peak abundance where every living thing is working at its maximum capacity. The gentle spring has matured into a season of vibrant, shimmering intensity, and the meadow is about to welcome its most high-energy visitor of all. As the sun reaches its zenith on this longest day of the year, a new sound enters the meadow, a sound that is distinct from the low rhythmic drone of the honeybee. It is a high-pitched metallic whir so fast it almost sounds like a sigh from the air itself. Out of the shimmering heat emerges a tiny iridescent jewel, a creature that is often called the meadow's jet engine. This is the hummingbird. To look at one is to witness a miracle of biological engineering. A bird so small and so fast that it seems to defy the very laws of physics. While you lie here in the stillness, your own heart beating in a slow, peaceful rhythm, the hummingbird is operating on a completely different scale of time. When it is in flight, its tiny heart can beat up to 1,200 times per minute. It is a pace that is almost impossible to imagine, a blur of internal energy that allows it to maintain its incredible lifestyle. This high-speed metabolism requires a constant high-octane fuel, and the hummingbird finds it in a very specific corner of the meadow's pantry. As we look across the sea of summer green, our eyes are drawn to a cluster of brilliant, flame-red blossoms standing tall near the water's edge. These are cardinal flowers. In the world of the meadow, these flowers are like a secret signal, a private invitation meant only for the hummingbird. You see, most bees perceive the world in a spectrum that favors blues, purples, and ultraviolet light. To a bee, a bright red flower often appears dull, almost black, and easy to overlook. But the hummingbird sees the full, vibrant brilliance of red. The shape of the cardinal flower is also a masterpiece of design. It is long and tubular, hiding its sweet nectar deep at the base of a narrow corridor. A bee, with its round body and short tongue, finds it difficult to navigate these deep wells. But the hummingbird is perfectly equipped. It possesses a long, slender bill and a tongue that can extend even further, lapping up the nectar with incredible precision. As it feeds, the flower's specialized stamens gently brush against the bird's forehead, depositing a dusting of golden pollen that will be carried to the next blossom. It is a partnership of perfect fit, a lock and a key. To reach these deep wells of sweetness, the hummingbird performs a feat of flight that no other bird can truly master, the hover. While most birds rely on the lift generated by flapping their wings up and down, the hummingbird moves its wings in a rapid, fluid figure-8 pattern. This allows them to generate lift on both the forward and backward strokes, granting them the ability to hang perfectly still in midair or even to fly backward and upside down. This hovering flight is one of the most energy-intensive movements in the entire animal kingdom. It is why the hummingbird must visit hundreds, even thousands of flowers every single day. They are forever chasing the sun, forever seeking the fuel that keeps their tiny engines humming. But as the summer solstice passes and the days begin their very slow, imperceptible shortening, the intensity of this midsummer rush begins to soften. The brilliant white-hot light of June and July starts to mellow. The air remains warm, but it carries a new weight, a sense of maturity. We are drifting now toward the golden light of August. The vibrant reds of the cardinal flowers are joined by a new palette, deeper yellows and rich purples. As the meadow prepares for its final most spectacular feast of the season. The high-energy buzz of the solstice is beginning to settle into a golden, late summer glow, where the pace of life slows just enough to catch its breath. As the golden light of August deepens, the meadow undergoes a final, breathtaking transformation. The landscape, once a tapestry of varied greens, is now dominated by two primary colors: the brilliant, sun-drenched yellow of the goldenrod and the deep, regal purple of the aster. These two flowers are the twin stars of the late summer meadow, and their arrival marks a profound shift in the rhythm of the year. There is a beautiful, quiet logic to why these two plants are so often found growing side by side. To our eyes, the contrast is simply pleasing, but to the eyes of a bee or a butterfly, it is a powerful biological signal. Yellow and purple are complementary colors. They sit on opposite sides of the color spectrum. When they are placed together, they create a visual intensity that is almost impossible for an insect to miss. By blooming in unison, the goldenrod and the aster create a luminous beacon that draws pollinators from far and wide. It is a partnership of mutual benefit, a cooperative strategy that ensures the meadow remains buzzing with life even as the days begin their slow, inevitable shortening. As you listen to the soft rustle of the late summer grass, you might recall the common belief that goldenrod is responsible for the seasonal allergies that many experience this time of year. But this is a gentle myth, a case of mistaken identity. The goldenrod's pollen is heavy and waxy, specifically designed to stick to the fuzzy legs of a bee rather than drift on the breeze. The true source of the sneezing is often the ragweed, a plant with small, green, inconspicuous flowers that bloom at the exact same time. While the ragweed releases clouds of invisible, wind-borne pollen, the goldenrod stands tall and innocent, its golden plumes swaying peacefully, offering a rich bounty of nectar to any traveler who stops to rest. This period is often called the final feast. For the inhabitants of the meadow, these blooms represent the last great harvest before the world begins to cool. The nectar found in the goldenrod and the aster is incredibly concentrated, providing the high-energy fuel vital for the trials ahead. As you feel the weight of your body settling deeper into your bed, imagine the bees working with a steady, rhythmic focus, gathering the last drops of summer's sweetness to sustain their hives through the long, quiet winter. But for some, this feast is not about staying, it is about preparing to leave. The air is beginning to carry a new crispness, a subtle hint of the coming frost that hasn't yet arrived, but is whispered in the evening shadows. This change in temperature, combined with the shifting angle of the sun, serves as a silent signal to the meadow's most legendary travelers. The season of wandering is about to begin, and the first of the great migrations is stirring. Small, delicate wings are being tested, preparing for a journey that will span thousands of miles across a vast and changing world, guided by ancient maps written into their very cells. Among the many travelers visiting the late summer blooms, one stands out for its silent strength and incredible ambition: the monarch butterfly. This small creature, with wings as thin as parchment and as vivid as a sunset, is preparing for a journey of nearly 3,000 miles. It will fly from the meadows of the north all the way to the specific mountain forests of central Mexico, a place it has never been, yet knows perfectly how to find. What makes this journey even more remarkable is the specific generation of butterflies that undertakes it. Most monarchs born in the spring and summer live only 2 to 6 weeks, focused entirely on the immediate tasks of life. But as the days shorten and the air cools, a unique generation is born, often called the Methuselah generation. These butterflies are biologically different from their parents. Their bodies are programmed to delay aging and reproduction, allowing them to live up to 8 months. They possess a physical resilience that is almost hard to fathom, a deep reservoir of energy that will sustain them across entire continents. As you breathe slowly, imagine these delicate travelers navigating the vast open sky. They find their way through a sophisticated internal navigation system that rivals as any modern technology. They use what scientists call a sun compass located in their brains, which works in harmony with a biological clock in their antenna. This allows them to adjust their flight path as the sun moves across the sky throughout the day, ensuring they stay on a steady southward course. Even on cloudy days, they are not lost. They have the ability to sense the Earth's magnetic field, following a silent, invisible map that pulls them toward their winter home. There is a quiet, moving tension in the image of a butterfly, a creature that weighs less than a single gram. Facing the immense scale of the world, they must navigate high winds, avoid sudden storms, and cross vast bodies of water, all while fluttering with a rhythmic, steady grace. Yet they fly on, a golden thread connecting the northern meadows to the southern forests. As the last of the monarchs rise from the goldenrod and begin their southward drift, a sense of completion settles over the meadow. The vibrant colors of the flowers are beginning to fade, and the frantic activity of the summer is transitioning into a steady, quiet rhythm. The plants have finished their bloom, their bright petals have served their purpose of attracting visitors, and now their energy is turning inward. The meadow is beginning to prepare for its own form of legacy, focusing all its remaining strength on the small, sturdy vessels that will carry the promise of life through the cold months ahead. The time of the flower is passing, and the intricate work of the seed is beginning. This is the payoff, the quiet, hidden reward for a season of sun and rain. While the petals of the wildflowers may have wilted and fallen away, their disappearance marks the beginning of the most critical phase of their life cycle. Inside the base of what was once a vibrant flower, a miraculous transformation is taking place. The union of pollen and ovula has created a new life, and now the plant begins the delicate process of turning a fertilized cell into a hardy, resilient seed. It is a slow, methodical transition, happening away from the eyes of the world, deep within the drying husks of the meadow's flora. When the pollen grain first landed on the sticky surface of the stigma, it grew a microscopic tube downward, reaching deep into the flower's ovary to find the waiting ovule. This union is the spark of the next generation. As the days grow shorter, the plant shifts its entire biological focus. It no longer prioritizes the growth of new leaves or the height of its stem. Instead, it directs every ounce of its stored energy, the sugars it gathered during the long, hot days of July, and the minerals it pulled from the deep soil, into these tiny vessels of life. It is a final, concentrated burst of energy, a pouring of the plant's very essence into its offspring. Inside each individual seed, a tiny embryo waits. It is a miniature map of the future plant, complete with the beginnings of a root and the blueprint for its first set of leaves. Surrounding this embryo is a concentrated supply of food, a dense reservoir of proteins and fats designed to sustain the plant during its first few days of growth in the distant spring. And wrapping it all is the seed coat, a tough protective jacket that can withstand freezing temperatures, heavy rains, and the weight of the winter snow. This small structure is a masterpiece of biological engineering, built to protect the fragile spark of life from a world that is about to grow cold and still. Think of the incredible variety in how these seeds are packaged. Nature is a master of design, and each plant has its own unique way of protecting its legacy. Some, like the milkweed, create thick, teardrop-shaped pods that start as a soft, waxy green. As the seeds inside mature, the pod dries and hardens, eventually splitting open to reveal a treasure trove of hundreds of seeds, each attached to a tuft of silken white floss. Others, like the burdock or the cocklebur, choose a more tactile approach. They create burrs, seed cases covered in tiny hooked spines that act like natural Velcro, ready to catch onto the fur of a passing fox or the fabric of a wanderer's coat. As you settle deeper into your pillow, feel the weight of your body mimic the grounding energy of the meadow. The plants are exhaling now. The green of the stems begins to fade to a golden brown as the chlorophyll breaks down, and the nutrients are pulled back into the seeds or down into the roots for storage. The meadow is no longer a place of bright, competing colors, but a landscape of textures, brittle pods, fuzzy seed heads, and sharp hooks, all waiting for the right moment to move. The seeds are now ready. They are packed, protected, and full of potential. But for the meadow to continue, these seeds cannot stay exactly where they fell. They must find new ground away from the shadow of their parent plant to ensure the cycle continues. This is where the mechanics of dispersal begin to play their part, turning the still autumn air and the movement of the earth into a highway for the next generation. Among the most graceful of these travelers are the wind riders, those seeds that rely on the invisible currents of the air to find their new homes. This ancient partnership between the plant and the atmosphere is known as anemochore, a word that sounds like a gentle sigh, derived from the Greek terms for the wind and the act of wandering. For these plants, the breeze is not just a movement of air. It is a vehicle, a courier, and a promise of a future. Consider the dandelion, often the most familiar of the wind travelers. As its bright yellow petals fade, it transforms into a delicate silvery sphere known as a clock. Each individual seed is attached to a structure called a pappus, a tiny, umbrella-shaped tuft of thin white bristles. While it looks simple, the pappus is a masterpiece of fluid dynamics. Scientists have discovered that as a dandelion seed drifts, the specific spacing of these bristles creates a separated vortex ring in the air directly above it. This is a tiny, stable bubble of low-pressure air that acts like a miniature vacuum, pulling the seed upward and allowing it to stay aloft with incredible efficiency. It is a porous parachute, far more stable and effective than a solid one would be, allowing the seed to remain suspended even in the slightest of breaths. On a warm afternoon, the air near the ground begins to rise as the earth radiates heat. These rising columns of air, called thermals, are the highways for the meadow's seeds. A single dandelion seed, weighing only a fraction of a milligram, can be swept up into these thermals and carried high above the trees. While most seeds land within a few yards of their parent, a lucky few can travel for miles, crossing over rivers, hills, and forests. There are documented cases of these tiny wanderers traveling over 100 miles before finally settling back to Earth. They are the ultimate explorers, silent and patient, trusting the whims of the sky to find a patch of soil where they can begin again. As you lie here, perfectly still, I want you to visualize one of these tiny seeds. Imagine it caught in a soft golden updraft as the afternoon sun begins to dip lower in the sky. See it dancing, spinning slowly, suspended in a state of weightless peace. It isn't fighting the wind. It is simply part of it. Now, imagine the wind beginning to settle as the day grows quiet. The thermal loses its strength, and the seed begins its long, slow descent. It drifts downward, inch by inch, through the cooling air. It falls past the tops of the tall grasses, past the drying heads of the wildflowers, moving slower and slower. Feel that same sense of gentle, effortless descent within yourself. Allow your mind to drift downward, just like that seed, settling into the soft, quiet depths of your own rest. The earth below is beginning to change. The vibrant, buzzing energy of midsummer has softened into a rhythmic, steady cooling. The light is different now. It is longer, more golden, and it hits the meadow at a shallow angle that makes every blade of grass cast a long, reaching shadow. As the sun sits lower on the horizon, the ground begins to release the heat it held all day, and a crispness enters the air. This change in temperature is a signal, a chemical trigger that moves through the stems and leaves of every plant in the meadow. The time for growing and wandering is ending, and the time for a different kind of transformation is beginning. The air is stiller now. The wind travelers have mostly found their places in the soil, and the meadow prepares to change its coat one last time before the long sleep of winter. As the sun continues its slow, low arc across the sky, the meadow begins a spectacular chemical transformation. The vibrant greens that define the summer are fading, not because the plants are failing, but because they are beginning a process of profound wisdom and conservation. This is the chemistry of autumn, a quiet masterpiece written in the language of pigments. Throughout the long, hot days of July and August, the meadow was dominated by chlorophyll. This is the molecule that captures sunlight and turns it into life. And it is so abundant and so intensely green that it masks everything else. But chlorophyll is a delicate thing. It requires a constant investment of energy and warmth to maintain. As the nights grow longer and the air turns crisp, the plants receive a signal to stop this production. They begin to break down the chlorophyll, salvaging its precious components, especially nitrogen. and drawing them back down into the safety of their stems and roots. As the green mask dissolves, the meadow's hidden colors are finally allowed to emerge. These are the carotenoids, the same pigments that give carrots their orange hue and corn its bright yellow. They have been present in the leaves all summer long, working quietly alongside the chlorophyll, but they were simply overwhelmed by the green. Now, in the cooling light, they reveal themselves in shades of ochre, gold, and amber. But the meadow has another secret, a more active one. On these clear, cool autumn days, some plants begin to produce entirely new pigments called anthocyanins. These are the deep reds, the vibrant purples, and the rich magentas. Unlike the yellows, which were always there, these reds are manufactured specifically as the season turns. Scientists believe these pigments act as a kind of protective barrier, a botanical sunscreen that shields the plant's tissues from the bright sun while it finishes the delicate work of moving its nutrients into storage. The result of this invisible chemistry is a visual tapestry that feels heavier, richer, and more grounded than the bright flash of spring. The tall grasses, like the big blue stem, shift from a dusty blue to a deep resonant mahogany. The ferns in the shaded edges of the meadow turn a brittle, pale gold. The asters and goldenrods, their petals now spent, leave behind heads of silver fluff and stalks of burnt sienna. This is the meadow in its most reflective state, a landscape of rust and gold that seems to absorb the fading warmth of the sun rather than reflecting it. It is a time of incredible stillness. The frantic growth of the year is over, and the energy of the earth is being pulled inward, away from the surface and down toward the dark, quiet soil. This shift in color and chemistry is a clear message to the meadow's many inhabitants. For the insects that spent their summer dancing between blooms, the world is becoming a very different place. The nectar sources have dried up, and the lush green leaves they once fed upon have become tough and papery. The air, which once hummed with the vibration of thousands of wings, is growing silent. The bees, the butterflies, and the beetles can feel the change in the light and the drop in the evening temperature. They know that the time for wandering has passed. They must now find a sanctuary, a hidden corner of this changing world where they can tuck themselves away. As the last of the gold leaves drift slowly to the ground, a new kind of search begins, a search for a place to wait, to rest, and to survive the coming cold. As the meadow's vibrant colors begin to fade into the muted tones of wood and stone, a profound silence settles over the landscape. This is the beginning of what scientists call the Big Sleep, or more accurately, diapause. While we often think of winter rest as hibernation, the diapause of an insect is something far more intricate and specialized. Hibernation, seen in mammals like groundhogs or bears, is a deep sleep where the heart rate slows and the body temperature drops, but the animal remains biologically active on a very low level. Diapause, however, is a complete physiological pause. It is as if the internal clock of the insect simply stops ticking. It is not just a nap. It is a suspension of life itself, triggered long before the first snow, by the shortening days and the subtle golden shift in the angle of the sun. To survive the coming freeze, these tiny creatures must perform a feat a biological engineering that seems almost like magic. They begin to freeze dry themselves. If the water inside an insect's cells were to freeze, it would expand into sharp crystals, piercing and destroying the delicate structures within. To prevent this, as the autumn air chills, insects slowly expel a large portion of the water from their bodies. They replace this moisture with natural sugars and alcohols, such as glycerol. This acts as a biological antifreeze, lowering the freezing point of their bodily fluids so they can remain in a liquid state even when the air around them is biting and bitter. In this state, they become still, heavy, and incredibly resilient, waiting in a state of suspended animation where they require almost no oxygen and no food. Now, the search for the perfect hibernaculum becomes urgent. This word, which literally means a tent for winter quarters, describes the many hidden sanctuaries the meadow provides for those who know where to look. A solitary bee might crawl deep into the hollow, pithy center of a dried raspberry cane or a standing goldenrod stem, wedging itself into the darkness. A ladybug might find a deep crevice in the bark of an ancient oak, huddling with hundreds of its kind to share what little ambient warmth remains. Others burrow deep beneath the thick, insulating carpet of fallen leaves, where the decaying organic matter creates a tiny, tempered microclimate, shielded from the wind. These tiny spaces are more than just shelters. They are the quiet, sacred chambers where life will wait out the long, dark months ahead. Each insect finds its own niche, a crack in a stone wall, a fold in a piece of loose, silvered bark, or a tunnel in the cooling soil. The meadow is no longer but a place of frantic movement and buzzing song. It has become a vast, silent dormitory. Every hollow stem and every layer of leaf litter may hold a tiny life, tucked away, perfectly still and dreaming of the sun. The air grows sharper now, and the moisture in the grass begins to glisten with a new brittle brightness. The first true frost is coming, a crystalline blanket that will soon seal the meadow in its long winter sleep. The first snow arrives not with a crash, but with a whisper. It begins as a few stray flakes, drifting aimlessly through the gray light of a late November afternoon, before finally settling on the brittle, brown skeletons of the summer's wildflowers. Soon, the individual flakes join together, weaving a seamless white shroud that covers the meadow from edge to edge. The world grows profoundly quiet. Snow is a natural acoustic insulator. Its porous structure traps sound waves, dampening the noise of the wind and the distant world until the meadow becomes a cathedral of silence. Underneath this cold white blanket, the plants of the meadow are completing one of the most sophisticated maneuvers in the natural world. While they may look dead to the casual observer, they are merely transitioning into a state of profound internal focus. This process is known as senescence. It is not a random fading away, but a highly regulated biological program. As the temperatures dropped and the days grew shorter, the perennial plants, the grasses, the coneflowers, the milkweed, began to systematically dismantle their own green machinery. They began by breaking down the chlorophyll in their leaves, salvaging every possible molecule of nitrogen, phosphorus, and potassium. Like a family packing up a summer home, the plants do not leave anything valuable behind. These nutrients are transported through the vascular system, moving downward, away from the frost-bitten air, and into the safety of the earth. They are stored in the roots, the rhizomes, and the bulbs, tucked deep below the frost line. Here, the energy is converted into concentrated starches, a biological battery that will remain charged and waiting through the darkest months of the year. The stems we see poking through the snow are merely empty husks, their purpose served, while the true heart of the plant beats slow and steady in the warmth of the soil. As you listen to the muffled stillness of this winter meadow, take a deep, slow breath. Feel the coolness of the air as you inhale, and as you exhale, let your muscles release their hold just as the plants have released their leaves. There is no longer a need to reach upward or to strive for the sun. The season of growth has passed, and the season of rest has arrived. Imagine the weight of your body against the mattress, echoing the weight of the snow upon the earth, a heavy, comfortable pressure that signals it is time to be still. The cycle that began with a single sprout in the warming mud of April has now come to its quiet conclusion. The frantic buzzing of the bees, the vibrant colors of the petals, and the long golden days of the solstice are all preserved now in the memory of the roots and the stillness of the seeds. The meadow has done its work. It has fed the insects, sheltered the birds, and scattered its legacy across the wind. Now it earns its long sleep. The landscape is a masterpiece, a white and shadow, a world held in a crystalline pause, where the only movement is the slow, rhythmic pulse of life waiting beneath the frost. The circle is closed, the energy is stored, and the meadow is finally, peacefully at rest. In this vast white silence, it might be easy to think that the story has ended. But in the world of the meadow, there is no such thing as an end, only the eternal return. While the surface appears frozen and still, the landscape is far from empty. It is merely holding its breath. Beneath the layers of snow and the cold crust of the earth lies what ecologists call the soil bank. It is a hidden treasury of life, a vast library of potential waiting for its moment to be read. Millions of tiny seeds are tucked into the soil, each one a biological time capsule. Some are the offspring of the flowers we watched bloom this past summer, but others have been resting there for much longer. These seeds are remarkably patient. Certain species of wildflower can remain dormant in the soil bank for decades, even half a century, waiting for the perfect conditions to arise. They carry within them a sophisticated chemical clock, sensing the precise moisture levels and the exact temperature of the earth. They are not dead. They are simply dreaming of the light, waiting for the specific vibration of the world that tells them it is safe to wake. This is the great, enduring comfort of the natural world. The rhythm of the seasons is a promise that is never broken. Even now, in the deepest part of the winter, the meadow is performing the quiet work of preparation. The very frost that seems so harsh is actually helping. It works to break down the tough outer coatings of certain seeds in a process called scarification, allowing them to finally absorb water when the thaw begins. The heavy snow is not just a weight, it is a reservoir, slowly filtering into the ground to recharge the deep aquifers that will sustain the grasses through the heat of July. Every cold night is a necessary step toward a warm morning. As you settle deeper into your own rest, let this certainty bring you a sense of peace. The meadow does not worry about the return of the sun. It simply rests, trusting in the cycle that has governed the earth for millions of years. You too can lean into that trust. Just as the meadow allows the snow to cover it and the wind to blow over it, you can allow the day to fall away. There is nothing left to do and no more facts to gather. The world outside is quiet, wrapped in its soft white blanket, and you are tucked away in that same gentle safety. The seeds are sleeping, the roots are waiting. The great circle of life is poised, silent and perfect in the dark. May your sleep be as deep and as restorative as the winter meadow, and may you wake feeling as renewed as the first green leaf of a new year. Take one last slow breath, feeling the stillness of the room around you. Sleep well, rest deeply. The meadow will be here when you wake, ready to begin again.